Hello, algebra students, and welcome to lesson 3-4 on arithmetic sequences. Yes, that is called arithmetic sequences, right? So this is a special topic in algebra. You're going to do two types, arithmetic and geometric. Arithmetic sequences are here because they are very much an application of linear functions. And we'll talk about that as we go through today. All right? Okay. Okay, so connect sequences and functions. Okay, is the ordered list 26, 39, 52, 65, 78 an arithmetic sequence? All right, so I think you know what a sequence is, right? A sequence is an ordered list of numbers, and often it forms a pattern. So a sequence are numbers that form a pattern, okay? So each number is a term of the sequence. First term, second term, third term. And to be, and I'll change colors, to be an arithmetic sequence, you have to have a common difference, which means that between any two consecutive terms, the difference is the same, a common difference. Okay, so very important idea here. All right, so let's write down these numbers. So in this list, in this sequence, the first term is 26, the second term is 39, I'll leave some space, the third term is 52, the fourth term is 65, and the fifth term is 78. So let's go through and find the common difference. So what is the difference from 26 to 39? Well, you're going to take the second number and subtract the first number. 39 minus 26. That's 13, and it's positive. So you're growing by 13, right? That's the difference. So you would do the same thing between each set of consecutive numbers. 52 minus 39, that's also a positive 13. 52 to 65, if you subtract those, that's also a positive 13. 78 minus 65 is also a positive 13. Because all of the differences is 13, this 5-number sequence has a common difference. Therefore, this is an arithmetic sequence. This is an arithmetic sequence with a common difference of 13. And there you go. So that's what this section boils down to. Can you subtract your consecutive numbers and get the same thing or not? If you can, you're going to be successful. Now, of course, we're going to build upon this, right? So it says, how are sequences related to functions? Well, let's talk about some things. So when you have a function, you have two major parts, the inputs and outputs. You have what are called the domains, the domain. And then you have called what's the range. So for the domain of any sequence, it's going to be the term numbers. So first term, second term, third term, fourth term, and so on. Right? These are the term numbers. Your range is then going to be the actual values in the sequence, right? So that would be, they call it A sub 1, A sub 2, A sub 3. These are the actual numbers. A sub 4, ... Again, this is just notation, right? These A's, so don't worry about that. And these are the actual terms. So like the 1, 2, 3, 4, we called them cardinal numbers, right? Cardinality, first, second, third, fourth. You learned that back in, first, second grade. And then the range are the term numbers. So if we use our previous example, right, our sequence was 26. I apologize. It was 26, and then 39, and 52, and 65, and 78. So the first term here, A sub 1, is 26. That's the first term. A sub 2, the second term, would be 39. That's the second term. And then you can go on forever. ... So the nth term, A sub n, all right, is some number. This would be called the nth term. Okay? So there we go. Right? That's how these arithmetic sequences are going to relate to functions. And again, linear functions. Okay, so here's a breakdown of what's called recursion or recursive, right? Recursive. So recursive in mathematics means to repeat a process over and over again. Repeat a process over and over again. And in this case, we're going to use the output of each step as the next input. So what we get from the previous step is going to be what we put in for the next step. Okay? So again, it relates each term of a sequence to the previous term. So each term, each input to the previous term, the output. Okay? So here is an example of a recursive formula for an arithmetic sequence. So you would identify what the first term is, so a sub 1, and then this would be your recursion or recursive formula. A sub n, we call this the next term. A sub n would be a sub n minus 1 plus d. A sub n minus 1 is the previous term. So when you see this n minus 1, that means it's the previous term. And again, this d is the common difference. So what's nice about a recursive formula is that it can be used to find the next term in a sequence, to find the next term. So if you need the next number, there you go. You have the previous number, take it, add it to the common difference, you get the next number. All right, pretty basic. All right, so let's take a look here at a problem. Okay, so it says, what is a recursive formula for the height above the ground of the nth step of the following pyramid as shown? All right, so here it says each step is 26 centimeters tall. All right, so we are going to let, again, we're trying to find the height above the ground for the nth step. So in this problem, we're going to let a sub 1 be the height of the first step. Well, that's going to be 26, right? Because that's where it starts. So the first step, so the first term is 26. That means that the first step is 26 centimeters off the ground. So then here's our recursive formula. A sub n equals a sub n minus 1 plus d. And this common difference here is going to be the difference as we go up these steps. Well, again, each step is 26 meters tall. So going from one step to the next step, you're going to add 26 centimeters. That means that this common difference, d, is exactly 26. This is your common difference. So then your formula here is just a sub n equals a sub n minus 1 plus 26. So if you were answering this question, you would tell me what a sub 1 is, and then you would tell me what a sub n is. Okay, so let's continue on to example 2b. I think it's going to use this formula now. So now it says, okay, use the recursive formula a sub n equals a sub n minus 1 plus 26, where a sub 1 is 26, to find the height above the ground of the third step, right? Okay, so we know that a sub 1 is 26. And we know that a sub 2, if we use this formula, right, would be a sub 1, which is the previous term, plus 26. Well, that would be 26 plus 26. That would be 52. This would be the height of the second step, 52. So now to find the height of the third step, again, we're going to take the previous term, which would be a sub 2, right? We're trying to find a sub 3, the third step. Take the second step and add 26. So we're going to take 52 right here, and we're going to put it in for a sub 2. And we're going to do 52 plus 26, and that is 78. So that third step would be 78 centimeters above the ground. So again, basic recursive formula. You just take the previous term and add the difference. Awesome, great. So this is the first video. Second video is coming right up next.